Okay. So anyways, welcome to the Starkle Planetarium at Parkland College. I am the director of the Starkle Planetarium, Erik Johnson. We're glad you could join us here tonight. We're doing these shows as a tandem where there's two of us working together. So with me here is also Waylena McCully. She's our show producer. You can see the other camera that's up there. Generally, we ask that you folks keep your mics off as well as your videos off because these shows are being recorded and will be shared on our YouTube channel afterwards. Okay, but if there's a question that you really want to ask using the mics, feel free to raise your hand or throw it up in the chat, and we will happily let you unmute your mics so you can ask the question in that comfortable way for yourselves. While the show's running, feel free to run some requests or questions by us in there at any time. I don't mind being interrupted because this is actually a pretty free-flowing show. If you want to make some requests, I would be happy to hear them. If there's a certain star or a planet or a constellation you want to see, I will be happy to show that to you all.
Yeah, just put it in the chat. I have no fear whatsoever in interrupting Erik to get him to talk about extra stuff.
That's right. That's right. Now, I see there's a lot of people here, and that's fantastic. These shows are generally running every other week, but we have also been doing monthly shows in coordination with our Kaler Science lectures. So, for example, next month is starting Monday, isn't it? In February, on the first Friday of the month, that is our Kaler Science lecture, the first one of 2021. We will be welcoming Dr. Jessica Conroy from the University of Illinois, and she's going to talk about climatology with us, and paleoclimatology with us. So we'll actually have two shows that night because then Waylena will be running Prairie Sky Spotlight, and it's going to be focusing heavily on the missions to Mars that we've had and that we have, because there are going to be 3 of them arriving at the red planet in a couple of weeks. So that's going to be a lot of fun. So feel free to join us again next week with that. Now, without any further ado, you see that I've been sharing my screen the entire time I've been talking. You are looking at a piece of software called Stellarium. This is an open source software that I have been using now for probably almost 10 years. I actually used this sort of software in a planetarium when I was in graduate school, but since coming to Parkland, I have been using it entirely from a desktop or from a laptop. I use this in my classes, and I find it's a good, quick way to share the sky with people and to encourage them to simulate the sky right from their homes as well. We have our lovely Digistar software that can render this render the sky in really high resolution that we normally show in there. But for the purposes of these shows, I find this is good for our rectangular screens. Now you'll notice, in addition to what you're seeing with the software, you see a very familiar setting. For all of you who have been to the Starkle Planetarium before, this is what it looks like outside of the dome during the day. Okay, so you're seeing the sky as it looks roughly today at noon. One thing you might not be able to see at the bottom, I can show you that the time right there is only a few minutes after noon today, right now. In this software, I can actually change what we see as our ground, as our landscape right here. I'll pop that up here. I could go and look outside of the Student Union of Parkland College with one option here. There we go. So you can see we're actually right outside of the Student Union there, and you can go and see Dodds Park there. And that automobile you're seeing right there is actually the automobile owned by the photographer of this. Our show producer, Waylena, she actually has one of those 360-degree cameras, and she took this photograph here and helped me upload it into Stellarium for use for programs just like this. She took one other photograph that I'm happy to show off. I know, I'm showing you prairie skies and you're seeing all this daytime stuff. That's not what you came in here for. All right, this last one over here is one that's actually outside of Champaign. What you're looking at now is the observatory operated by the Champaign-Urbana Astronomical Society. They now call this Prairie Winds Observatory, and if you've ever been out there among the cornfields on any slightly blustery day, you know that prairie winds are things that flow through eastern Illinois quite often. So that roof on there, it's actually a roll-off roof, and there are many telescopes set up inside. And when we actually can meet in person, I highly encourage you folks to go out there and visit, because you can get some pretty good dark skies because you're a few miles outside of town. They frequently have open houses that are welcome for families to come and go and look at the sky and look through some telescopes as well. The reason why I'm out here as part of this system is because I also wanted to get out of the way of the buildings and the trees. We're going to go ahead and watch now the sun move across the sky. We're going to go a little bit later into the day there. This is going obviously a lot faster than what you'd normally see here, but we're going to go ahead and see the sunset. And it did roughly around 5 o'clock today. I don't remember the exact time because, you know, I didn't look that up beforehand. So you see the sky is changing very nicely right there. I'll pause it here at this moment. I want to see if there's anything I can look for right now. You are starting to see a couple of stars, and I have to admit, you probably would not see those in a normal sky. And the reason for that is just because when this software is being streamed through a Zoom meeting, I'm always worried about the resolution. So I had to go and amplify the brightness of those stars just to make sure things looked really nice and noticeable. But that's going to be a part of the sky we'll be looking at very shortly. What I don't see are any bright planets coming up immediately, and that kind of makes sense to me. So let's go a little bit later. Ooh, there's some bright stuff that came up right over here. If memory serves correctly, I think we might have maybe 1 or 2 planets coming up right after sunset. And the first one I can imagine is probably this fella right here. We'll see if this actually gives us anything that we can notice. Just having a quick look to see if maybe I'm accidentally looking at a bright star for a second.
And by planet coming up, you mean
Going
coming
down.
up in the order of business. Yes, not because they're going down over there.
That's a very good point. So that's what happens when I'm freely talking. I just am occasionally stumbling over my words. That's all right. So thanks for the interruption there. So a lot of you folks probably were looking out at the night sky last month because of the great conjunction that we see about once every 20 years. You were looking for Jupiter and Saturn. Notice that this evening, you're not seeing Jupiter and Saturn very easily next to each other. And that's just because it's been 6 weeks since that conjunction, the sun has gotten a lot closer to those planets. So it's going to be a lot harder to see them after sunset. With as low as this object is, this one might be pretty tough for us to catch in our night sky. I'm going to go ahead and zoom in on it so we can see if we've actually got a planet coming up here. We do not. I thought we were looking, that's right, I know what we're looking at right there. So you'll notice that we've got something that looks almost like the moon, but it's not quite the moon right there. I had a feeling that we were going to see this fella. A couple of weeks ago, we had some interesting views that were not visible around here because you might remember the beginning of January was entirely clouded out throughout all of East Central Illinois. But for other observers in clearer skies, they got to see this little beautiful triangle right after sunset. Jupiter had been drifting a little bit farther east from Saturn, so they were farther apart from each other. And then there was a little planet that's very close to the sun, zipping around the sun about once every 88 days that came close by those other 2 planets and made this adorable little triangle in the sky. And that's the planet you're seeing right now here. The 2 planets that are closer to the sun than Earth both show off phases just like the moon does. That said, I've zoomed in so close here. This is something I don't expect any of you would be able to see, certainly not without a telescope. And even with a telescope, I've never seen the phases of this planet. This is the planet Mercury you're looking at right here. Okay, you heard me talking about how it zips right past the sun. It's the closest planet to the sun. Being so close to the sun, the gravity of the sun tugs it in its orbit at a very high speed. So it moves just as quickly as the sun does across the sky, and it very quickly moves around the sun. Okay, so yeah, that's Mercury right there. I do admit I was zooming in so quickly, I was like not quite certain. Now, for those of you who are wondering where Jupiter and Saturn are, another thing I can do with this software, I can actually take away the ground entirely. Notice right down there, that glare is where the sun is at, and you can see a couple of bright dots right there. I'm going to go ahead and turn on some planet labels just so you can see which is which. I've got some guesses as to what we're looking at right here. Yep, there we go. So there's Jupiter, there's Saturn, and there's Venus. For anybody who had been with us 2 weeks ago, you can see how close Jupiter and Saturn were to the sun then, and you can see how close Mercury was. So this is what I was talking about right there. Roughly around January 10th, you had Jupiter and Mercury and Saturn very close to each other. But now, as we get to today, you see that Jupiter basically rose and set with the sun instead. Okay, so yeah, nothing doing for you looking for Jupiter or Saturn right now, but in a couple of weeks, you might be able to catch them a little bit before sunrise. So if there's anybody in the audience here who actually gets up that early or has kids that get them up that early, it might be something to check over in the east before sunrise. Okay. All right, so I'm going to go ahead and deselect Mercury once again. Mercury is, it's tough to really find in the sky, seeing how close it is to the sun and how quickly it zips around. But earlier in the year are often your best opportunities for looking at it. And we've got a couple coming up in the coming months. Like I said, this will be a bit tough to catch because of how low Mercury is, but it might be worth venturing out to see if you can do that on a clear evening. Okay, now, as you just saw, most of our planets are right next to the sun, so it's going to be a little tough to catch them. That said, though, we've got a lot of bright stars over here in our eastern portion of the sky. And I think you can probably recognize a couple of the shapes made by the stars that we can see right here. I saw one person make a couple of annotations earlier, and I'm going to do them myself before I actually show how this software connects the dots. I mean, if I've got it in Zoom, I might as well flaunt the fact that I can draw on my screen. So we see these 4 stars right here, 4 very bright stars, and I'm guessing none of you can really miss these 3 bright stars in a line right there. Now, you could see these making all sorts of various shapes right there. Okay, Waylena, what did you say was your favorite shape that this makes again? Put you on the spot, didn't I?
My favorite is usually the butterfly, but bow ties are cool, so I kind of like bow ties.
Butterflies and bow ties are good, yeah. Maybe you see it like an hourglass.
Show them next week.
Yeah, that'll be fun. Yeah, you could show it that way that next week. And maybe you might even see it looking like a dog bone, okay? But here, I'll go ahead and put up some actual pictures with this. Turn off those annotations there. And I'm going to select one of these stars right there, and I'm going to see if pressing C causes some chaos. Ah, it only turned on that one. Beautiful. Now I'm going to go ahead and press some artwork. So you see, this is a guy who apparently is kneeling on one leg right there, and he's got some animal in his other arm, and I think he was pretty successful in his hunt. You are looking at Orion the Hunter right here, okay? And if you're curious about this star right there, you'll notice that that star has actually quite a different color to it compared to the other stars in the sky. You might see that it's got kind of a tinge of red to it, as opposed to these stars looking white or blue. okay? And usually, actually, when I'm talking to my students to help them remember the name of this star, I tell them that it kind of looks, maybe you could say it looks beet red, okay? Maybe it's not beet red, I admit, but it really does help when we're talking about the star known as Betelgeuse, okay? Beet red Betelgeuse, right? So that's what you're seeing right there. Betelgeuse is in the constellation of Orion. How many times have I said that name? Just twice, right?
Mm.
Yeah, well, I won't say Beetlejuice a third time. Oh, I'm sorry, my bad. So yeah, I know. I love referencing movies that came out 30 years ago. I'm sure the kids will love that one. So make sure that they all watch that one when we're done with this.
A lot more than 30. Oh,
Yeah, it was a little bit more than 30. It came out in 1989.
oh
So
yeah.
yeah, I know. Just feeling as old as dust now. All right, perfect. So yeah, so that's the constellation of Orion right there. And I find that it's a great anchor for helping you see everything over here in this part of the sky. We call these our winter constellations because in the winter months, they are coming up basically right after sunset. You can see these constellations basically the entire night, okay? They're not going to be right up high in the sky right after sunset, but you're going to see them that whole night. And so with them being in the opposite direction as the sun, it will be an optimal time for looking at them. Now, using Orion's belt, we can use that to point to all sorts of fun things. We might even point to a couple of things that we would regard as fall constellations as well. So I think I'm going to go ahead and do that. The first thing I would do is right here, I would point like this, and we're going to go right up this way from Orion's belt here. And notice that where I pointed to, we found first this V shape made by the stars. And in addition to that, we also found this neat little cluster right there. Okay, so with this one, there's a good way I like to always describe this. Let me turn that off for just a second. What we have done just now is we have pointed to the Pleiades, okay? Let me see if I can actually bring up the Pleiades on here. See if, that brings up a lot of stuff, I know. All right, let's see if I did this. Okay, perfect, there's the Pleiades. Okay, so the Pleiades is probably one of the most famous clusters in the sky. And many different cultures have all sorts of different names for them. Another really neat piece of information you can do with Stellarium is that you can actually look at the star lore of all sorts of cultures all over the world. You can see cultures from the Native Americans, you can look at Polynesian cultures, you can look at Asian cultures, and so on. And you can see what names for the constellations are given. And you can see how they actually connect the dots in very different ways from what we do. One such example of this with the Pleiades, you see them referred to as the Seven Sisters right here. And then you see apparently they've been endorsed by a car company. Maybe that's not exactly what we're talking about right here. The whole point is the car company Subaru got their name from this cluster of stars. In Japan, they refer to this cluster as Subaru, okay? It is the 5 that are 1. The next time you look at that automobile, look at its marquee on the front, right there by the hood, and you will see 6 stars as their logo. Okay, it's because the company formed from the merger of 5 other companies. That's where it got its name from. All right, so yeah, a very bright, famous cluster right there. And when you zoom in on it, you actually, let me actually turn off my annotations before I do this. There we go. When you zoom in on this, you can actually see some really beautiful stars. And notice they look all nice and white and blue right there. They're very young, hot, bright stars in a nice close cluster. When people look at this, they often see it actually kind of looks like a tiny little dipper up there in the sky. So I've had some people tell me they thought they were looking at the Little Dipper right there. But I would say that if you wanted to give this the nickname of the Micro or Mini Dipper, you're more than welcome to. And that actually reminds me that we should actually probably go and find the Little Dipper when I go through this tonight. Okay, oops, zoomed out way too far right there. Okay. If you're curious about what constellation the Pleiades are in, that V shape I was pointing out before will give you a really good sense of where we're looking right there. Notice that going up from the V shape, we've got this right here and we have this right there. Those are the horns. And you can see the Pleiades are over in the back right there. And they're actually riding on the back of the bull. That's a pretty big bull if there are 7 sisters that are able to fit on its backside right there. So yeah. So nevertheless, you might know the name of the bull constellation. It happens to be Taurus. So the way you can imagine it is that Orion is fighting Taurus in the sky constantly right there. Now, Orion being a hunter, Orion probably needs some companions to help him on his hunt. You know that hunters often bring dogs with them, right? Well, you can find Orion's dogs actually are rising right now over in the east. There are 2 Orions left. Let's go ahead and go a little bit later so that all of them come up. You notice the sky actually got a little bit darker there because we still had a little bit of residual twilight. So the first of these dog constellations we can find, we're going to take Orion's belt and head on down to here to this bright star. And actually, I shouldn't just say bright star, I'm actually talking about the brightest star. We're talking about the star Sirius. And of course, I forgot that I had the other stuff up there, so that just kind of gave away exactly which dog we're looking at right here. It's known by the name Canis Major, which in Latin literally just means big dog. Okay, simple as that. Sirius is often known as the dog star, and now you understand why. For those of you who have read or have seen the Harry Potter series, you might now understand why Sirius Black turns into a dog. Okay, that's where J.K. Rowling got the name from. If you look around the sky, you'll find all sorts of other names that she borrowed for the names of characters and so on. One example is actually in the constellation of Orion. The right shoulder is actually named Bellatrix. Okay. Now, I was telling you about the dogs of Orion, and this is Canis Major. Maybe you're imagining to yourself, well, that means that if there's a small dog, in Latin, that would be Canis Minor. And you can find that one just up from Canis Major. There's a bright star right here, and there you can see Canis Minor with its bright star Procyon right there. Now, with this one, we actually have a lot of fun with this constellation because take a look at all the stars that make up Canis Minor. Yeah, all 2 of them. Okay, all 2 of those stars. And you look at that and you go, wow, they really just connected 2 dots to make a small dog. Well, it is a little dog. Okay, sure. Lots of imagination is involved with that one right there. But we hope you can join us again in the planetarium because we have a lovely piece of art where we replace that dog with a hot dog. I'd say a hot dog constellation is probably a lot better to remember right there. Okay. Now, another thing that you can notice just down into the left of the dogs, probably pretty hard to ignore, you probably saw the moon coming up right there. Did any of you see the moon this week? Yeah, I know I did. I saw it once or twice there popping up through the clouds and also on some clearer nights. You might have even heard about the terms like wolf moon being bandied about. It was the wolf moon this month. Is that right, Waylena? You're kind of nodding there. Yeah. So if you have looked in an almanac or looked at these various names for moons, I do have to admit, oh, Jermaine's looking at the moon right now. That's wonderful. I never have memorized every single one of those names of the moons. They're not names that are given by astronomers. A lot of them actually have to do with what you're doing at that time of the year. Some of them have actually agricultural significance. Some of them have significance to the Native Americans.
And that they vary by region too.
Yeah, exactly.
So one part of the country, you'd learn it one way, and another part.
Right. Yeah, there's a lot of variation. The big reason why this moon is referred to as the wolf moon is because it's in a part of the sky that it gets up really high at night, okay? The full moon is in the opposite place in the sky as the sun is. So when the sun is in December and January, the moon, when it's full, is in the part of the sky where the sun would be in June or July, okay? And you know that sun gets really high up in the sky during June and July. So having a moon get high up in the sky each night, you know the wolves are going to love that, and they're going to want to howl at that moon right there. Okay. Yeah, you don't need to hear my wolf howl. That's all right. But yes, that is called the wolf moon because the moon gets up really high that night. There are other names for the moon throughout the year. There's the cold moon. I think that one's self-explanatory. You might hear about a strawberry moon, and that one I think is from around the time that strawberries are actually starting to bear fruit. You've got your harvest moon, again, pretty self-explanatory. Hunter's moon, they're going off and hunting for certain animals at that time of the year, and so on. So there's 12 of those names, and as Waylena said, you might have alternate names for each of those moons. But sometimes in a year, you might get 13 full moons. And if whatever full moon you get, that's the extra one within a season or within a calendar month, that's the one that you refer to as the blue moon. So blue moons are actually connected to those other moons right there. All right, it's that extra one that we find about once every 3 years on average. Is that the right average? It's once, roughly like that. We get, yeah, we have about 11 extra days in a year after having 12 full moons. So it's somewhere around there. Okay. For more information, compare your Jewish calendar to your regular calendar. You'll figure it out from there. Okay. They have extra months as well. That's where I'm getting it from. All right. Okay. So with that, I think I'm going to turn off all of this good stuff with Orion and with the hunting dogs and with Taurus. And I was talking about wanting to show off those dippers, but I did just remember that I do want to at least look at what the moon looks like tonight. You saw probably a full moon last night. So I'm going to show you what the moon looks like tonight. Okay. There we go. So this moon looks pretty full, doesn't it? That said, though, I see a tiny little sliver of darkness over on this side. This lunar sea that you see right there doesn't look completely lit up. What you're seeing is that the sun is just barely starting to set on that portion of the moon. So this is a moon that's actually 1 day past full. All right, and you can really start to see this in the subsequent days. So I'll show you what the moon is going to look like tomorrow. That's tomorrow. That's the day after. That is February 1st right there. Okay, so now you start to see we're really starting to lose the moon. So after the moon is full, you see the moon is starting to wane. Oops, I went back a day back again. Okay, so you see the moon goes back to being a crescent. Ooh, look at that. It's right in front of a fun nebula. And the moon will eventually pass right by the sun, and that would be the next month right there. So I've gone up about 2 weeks right there. All right, let's get it back to today right here. So yeah, if you saw the moon last night or the night before, the moon might look lower than it did at the same time you saw the day before. And that's because constantly the moon is orbiting around Earth. All right. And that means that the moon will be in a slightly different part of the sky than it was the day before. It's the moon's orientation between Earth and the sun that gives us its phases. Okay, so its angle between them and the sun means that we see different amounts of the moon being lit up. The part that looks dark, it's the part that's not pointing towards the sun. So when you were looking at the moon yesterday, the moon was actually in this part of the sky. That's the moon where it was yesterday. And then the moon tomorrow is going to be right down there. Okay, looks like subtle differences from one night to the next, but it really does start to add up. Okay, so that's giving you a little bit of an idea of how the lunar phases work. It's all based off of the moon actually orbiting around our planet and where the moon is in relation to the sun. Okay. Now, let's go ahead and I'm going to bring us over to the northern part of the sky. Okay. Ooh, I don't have to go that far north right there. You'll notice over here in the northeast, there is a very famous group of stars. And this one I do definitely have to draw because you're not going to see it look the same when I actually bring up the constellation itself. Okay, so there's 3 stars right there. There's 4, 5, 6, 7. And here, I'll bring that right back there. So that one probably looks pretty familiar to a lot of you. This one, just like we've been talking about before, goes by many different names, okay? If you're from Britain, you might have heard this called the Starry Plough. If you're from other parts of Northern Europe, you might have called this Charleswain or Karlswagen, okay? They refer to it as a cart, as a car. I think, Waylena, we have one where they're called the bureaucrats, aren't they? Or do I have that right? Okay. And
yep, bunch of politicians in the sky.
That's right. That's right. So people have given this other names, but here in North America, we usually refer to this as the Big Dipper. Okay. And then if you ever see what the Greeks or the Romans ever called it, they're going to show you something slightly different. Let's go ahead and click on this and see what we have. Don't worry about that name right there. You see that they've got a lot more stars in there than just the 7 I pointed out. And you see that they are looking at, oh, look at that. That's all of them, isn't it? All right, we'll just look at this one for now. So you're now seeing what looks like a bear, all right? Bear is maybe not terribly accurate. The bear apparently decided to take the tail from a golden retriever or something. But it is still a bear you're looking at right there. And that bear goes by the name of Ursa Major, which is, just big bear in Latin. Okay, so the Greeks and the Romans saw a big bear right there, and we see the Big Dipper. Okay, and with the 2 stars right here, Dubhe and Merak, those 2 stars are referred to as the pointer stars because you can draw a line with those pointer stars to this star right here. And this star is known as Polaris. And you'll notice that Polaris also helps you find Ursa Minor. And yeah, it's a smaller little bear. Probably doesn't look much like a bear to you folks, especially not because this bear apparently has a tail as long as its entire body. Those anatomically incorrect bears, I tell you, I don't know what bears those Greeks or Romans were seeing, but I guess they just weren't seeing the rear ends of them. Nevertheless, I think you folks probably would prefer to refer to this as the Little Dipper right here. Okay, so Polaris ends up being at the very end of the handle of the Little Dipper. And you might know Polaris by a couple of other names. It's known also as the North Star. Polaris is also called the Pole Star. And the reason for that, here's another cool piece of information I can share with you folks. Here's what we call the celestial sphere. That grid pattern you're seeing right there is the same sort of grid pattern I have on this lovely device right there. This here is a celestial globe showing all the stars right there. You might not be able to see this, but I'm trying to show it on my camera right there. So at the very top of that globe, that's where the celestial poles is, the North Celestial Pole, and that's where Polaris happens to lie. So Polaris got its name from being that pole star right there, and it got its name for being the North Star because watch this as I go later into the night. You see over in the eastern part of the sky, the stars are rising. You see over in the western part of the sky, the stars are setting. You see that there are some stars that actually don't go below the horizon at all. But then you look at Polaris and it looks like it's stuck. Okay? Since Polaris is right next to the North Celestial Pole, Polaris hardly moves at all. It's pretty much stuck there in the sky. And that, you can imagine, would be really useful for people. Okay, Polaris had been used as a navigational tool for centuries, and that's where it got its name. It's often even called as a lodestar in that way. So you've got those magnetic compasses that can tell you which way is north. You've got your phones nowadays that can tell you which way is north. But before then, before we had that technology, we could use Polaris to help us with our guidance. All right, a very useful tool. It tells us exactly which way is north. So that's why we call it our North Star right there. It always stays in the north. Now I've gone much later into the evening. This is actually at about 3:15. So we're seeing a much, much different sky. Look at where the moon is. Now it's actually over in the southwest. Holy cow. You look at this right here, and I think actually, yeah, I think that we have your Orion has already set, hasn't it? The only one of the stars that I showed you before that's still up, we still have our hot dog, okay? So our hot dog's still there, but we have a radically different sky that we are looking at here, all right? So I guess I could show you a couple of other things that we can find in this part of the sky. Notice that actually right below our bears, this is technically part of our spring constellations, but I like this constellation so much, I want to share it with you all. The constellation that the moon happens to be in right now, I'm going to go ahead and share that with you all. Let's see here. I want to turn these off just so it doesn't get too surprising. All right. So for this one, the way you can find it, and I'll draw this out here because I just like doing this to help you see it. You've got these two stars, 3, 4 right there. I always see kind of a trapezoid with that. And then in addition to that trapezoid, this bright star here, I can draw out what looks kind of like a backwards question mark. But since we all love referencing the Cold War, which, like Betelgeuse, ended 30 years ago, we often call this the sickle, okay? So that's what you're seeing right there. And so this constellation has this here. The sickle is actually where you find the mane of this animal, and then there's a tail right here, and then there's some hind legs here, and these are the forelegs right there. So I will no longer keep you sitting at the edges of your seats, and I will show you what constellation we're looking at. There you go. You see, I kind of drew it pretty well there, but now you can see the artwork. You probably know the name of the lion, don't you? Yeah, this one is Leo. Leo the lion, okay? And that's just because Leo is the Latin word for lion, all right? So yeah, the moon is actually in the constellation of Leo tonight. And if some of these constellations have some familiar names, it's because Leo is one of those zodiac constellations right there. All right, the constellations that the sun passes through in that part of the sky. Let's see here. If you're curious about another fun way to find Leo, because I was just so inspired by this, you remember how I actually took these two stars in Ursa Major in the Big Dipper, the pointer stars to Polaris? If you take these two stars right here, you can actually go right to Regulus, okay? Let me see if I can do that for you all right here. Right to Regulus. Not a perfect line right there, but that's one way I help try to remember these parts of the sky. The bear and the lion are pretty close to each other right there, okay? So that's what you're seeing. You're seeing how Leo is very close to the Big Dipper. All right. Now, let's see here. I'm betting you folks want to find a couple more planets. And we do have one other planet here, but I went and missed it, didn't I? Did I already let that other planet set? Should I really be apologizing for that? I probably should. I am completely misremembering exactly where it needs to go. Waylena, will you forgive me if I go and rewind the sky?
Pretty sure that's what computers are made for.
Oh, is that right? Okay. Huh, there it is. There it is, the one that I missed because I was so fixated on all those that you can find over in the winter sky. So the last of our planets that I know you folks love to look for is the one that's going to be the main focus of our Prairie Sky Spotlight next week. You can find it over here down and to the right of where Taurus is. If you don't remember where Taurus is, look for that V. The V is right here. And just down past the Pleiades, you can find this object, apparently in the constellation of the Ram, Aries. And here, I'll go ahead and zoom in on it. Let's go and find it right now. Oh, look at that. We got a couple of other objects right next to it. Those are its bright moons. Okay, and by bright, I mean you're not going to see them really without a really strong telescope. They're very, very small, is why I say it that way. So you are seeing the red planet right here. This is the planet Mars. Okay, Mars is always the subject of a lot of interest by us because it's a pretty close planet. Since it's farther from the sun, we can see it the entire night. It can get pretty far away from the sun. Since it doesn't have a thick atmosphere, we can look at the surface. We can see ice caps on that surface. We've sent lots of space probes to orbit it and land on the surface, and we've got more going there right now. The US sent one that's going to be landing on the surface in just about 3 weeks. All right, and the Chinese have one that's going to land on the surface as well as orbit. And I believe the United Arab Emirates launched one from Japan that's going to orbit around the planet as well. Okay, so there are lots of missions to Mars being sent by many different space agencies.
Mars is under attack.
No, Mars is attacked. Is that right? That's right. Okay. We get a little punny around here. All right. So there you go. And I will turn off Aries as well. Let's see here. I'm guessing maybe, do we have, yeah, there's no other planet that's visible to the naked eye that I haven't accounted for. Certainly others that are around. We had one situation where actually a couple of days ago, Mars was very close to another planet that you could have been able to see it with binoculars. And I'll bring that up right now. We had one, Dave actually shared this with his Prairie Skies column in the News Gazette, and I'll show it off here now. This was around the 20th, I think, that you could see this. Okay, so there you've got Mars right there. And I think when you looked through binoculars, and binoculars is a great way to look at all of these objects in the sky, and you zoomed in real close, you would find another bright object in its vicinity. And it's actually, this is right here. I think this is the planet, if memory serves correctly. And I'm going to click on it and find out I'm wrong. Let's find out. I was right. Huzzah. Okay, so this object is the planet Uranus right there. Uranus is not visible to the naked eye. You need binoculars or a telescope to see it. I've seen it a few times with my telescope, but it's hard to see any features because it's a gas giant and it's got this layer of haze that blocks any sort of cloud features from being seen on the surface. It's not as cool to look at as Jupiter or Saturn are. Now it does have rings like Jupiter and Saturn do. They have better rings than Jupiter does, but not as good of a ring system as what Saturn has. So if you look at Uranus in this software, take a look at what you're about to see. Yeah, lots of fun moons, isn't that nice? It tries to simulate what those rings look like right here, but from Earth, you're only going to see those rings if you're using infrared, okay? You can't see those with visible light. So this one is not trying to represent what it looks like with your own eyes. And in addition to not seeing what it looks like with your own eyes, the cloud striping that you see right there, the belts and zones of Uranus, with the naked eye, it would be a completely featureless sphere. It would just be this pale blue color, almost kind of a blue-green, like a cyan color. That's all you would get, okay? But I have seen that little pale blue dot through a telescope, okay? I can tell it's a dot as opposed to a point of light, which is what you would see with the stars. And that's just with a 6-inch telescope. All right. So with that, let's go ahead, and now that I've already rewound the sky, I think I will now bring us back to today, And I will bring us now to roughly around sunrise. So we're going to look over here in the east. There's our moon rising a little bit after sunset because it's a little bit after full moon. And we'll watch everything moving off up there. You see the Big Dipper rising once again. You see the moon over there moving slowly through the constellation of Leo. That bright star that you see right there, we have a really fun way to remember its name. You see the Big Dipper here. That's right. Let me see if I can draw a nice curve here. I bet you I won't. This here is the handle of the Big Dipper, and you see it looking kind of like a circular arc. So we tell people to follow the arc to the name of this star. We follow the arc to Arcturus. Okay, and trust me, if you're looking for it, you can't miss it because this is one of the brightest stars in the night sky. Okay, follow the arc to Arcturus right there. The other fun thing about Arcturus is the constellation it happens to be in. There, it kind of looks like a kite or maybe a fish. I've heard it described both ways. You see it looks like a person holding a sickle, I guess, and a spear, but its name is one that a lot of people get a little bit of amusement from it because they look at that and they're like, wait, there's a constellation named Booties. Yeah, makes a lot of people chuckle. But I will just share it with you right now. Try to pronounce this name with the O's as two separate syllables. Bootes. Bootes. Okay. But yeah, Arcturus is in Bootes. But if you want to make people giggle, go ahead and just pronounce it Booties. I'm not gonna enforce proper pronunciation. I just wanted to share it with you. Okay, let's go a little later here. All right, this is the sky right after midnight. And we continue on right there. All right. More things are coming up. I'm starting to see some of the stars that we see in the summertime, including Waylena's favorite. Yeah, yep, I see her just going absolutely bonkers over there on her screen. Over here in the southeast, there's a really cool constellation with a really fun, very red star. And this is the path that the sun takes through the sky. And that means it's the path that the planets and the moon also take through the sky, very close to this star. And that star, because that red color often gets it mixed up with the red planet, as we talked about, that's where it gets its name Antares. Ares is the Greek name for the god of war, and Mars is the Roman name for the god of war. So basically, the name of this star just means not Mars. Okay. I don't know if anybody actually ever mixed those two up. I think it's really a good way to just say that they were offered in comparison to each other. Okay. The comparisons were inevitable, especially because at that time that it got named, people didn't even understand how planets worked. They didn't know that there was a fundamental difference between planets and stars. They just saw that the planets were moving through the sky compared to the stars. That's where the planets got their name. Planet just means wandering star. So you can see why the comparisons were made at that time. You'll notice our sky is getting a lot brighter here. This is the sky a little bit after 6 a.m. You would really start to lose a lot of these stars due to that twilight. I don't think we're going to be able to see Venus before the sun comes up, but we'll take a look. Yeah, Venus is really close to the sun right now, isn't it? Isn't that what we saw earlier? Maybe that's Venus right there, or is that actually Jupiter coming up right before, or is that Saturn? Well, won't know until we find out. There's Venus. Okay. I would imagine that if that's when you're seeing Venus, you're not going to be able to catch it. If it's rising less than 20 minutes before sunrise, you won't be able to catch that. So don't bother looking for Venus this morning, okay? It's not going to be that good of a morning star. If you're really wanting to see Venus, I would say you might have to wait until later this year when Venus becomes an evening star. Once again, it'll be setting after the sun, but it's setting at such an angle that it'll be really hard to catch until almost halfway through the year. Okay, so it'll be fun to look at as always, but it's just that now is not the time for it. Pick your spots. Okay, well, folks, I have been with you apparently all night. It is now tomorrow morning right there. Hopefully you can get some rest. I tell you, with astronomers being up all night, they do have to find their sleep somehow anytime during the day. But nevertheless, since you're here with me, I would be very happy to answer any questions that you folks would have. Feel free to type them into the chat or raise your hand, and we will not mind if you want to ask the questions over the microphone. Go for it. Oh, you're very welcome, Matt Nelly. If you have other requests about other things you'd like to see with the software, I'd be happy to share that as well. Show you where Libra is. I'd be happy to, Krishna. Okay, so it's actually in a part of the sky that's up right now. What I'm going to do is I'm going to take away the atmosphere. So everybody, please hold your breath. Okay, right here is where the constellation of Scorpius is, right there. Okay, and just to the right of the constellation of Scorpius are a couple of stars that were actually, in a way, stolen from the constellation of Scorpius. Notice that you can easily see the tail of the scorpion, and Antares kind of represents the head, but I've heard Antares also referred to as the heart of the scorpion, and these three stars here would represent the head. Okay, and it makes a lot more sense to have those two. What are they called? Oh my gosh, I can't remember the name of their pincers. There's a technical term for the name, but I've completely forgotten it.
I just call them claws.
Yeah, exactly. But the claws or pincers that you see there, it doesn't look very symmetrical, but these two stars to the right here are actually stars that got their names from being the claws of the scorpion. That said, though, they're clearly in the constellation of Libra. And these two stars have probably our favorite names for stars in astronomy. Notice that this one is Zubina Shamali, and then this one is Zubin al-Janubi right there, okay? Zubina Shamali comes from the Arabic meaning the northern claw star. And then Zubin al-Janubi is the southern claw star, okay? There's lots of literal translations and transliterations of names that we use in astronomy.
Erik, can you show the ecliptic?
Yes, absolutely. Thank you very much for the reminder. Libra is another zodiac constellation. So Scorpius, Sagittarius, Libra are running right through there. You see how Leo's right over here along with our setting moon. And the one that I have not shown is the one that covers the most space on the ecliptic. This is Spica in the constellation of Virgo right there. Okay. So your zodiac constellations are running through there. Looking at where the sun's at right now, I'm guessing the sun has moved into the constellation of Capricornus. Yep, there's your sea goat.
Oh, could you show Ophiuchus?
Absolutely. Good point. Notice there's a tiny little gap right here. There's a couple of stars here that are not actually in these zodiac constellations that I've just shown you. If you've heard about the zodiac having 13 constellations, it's because this 13th one here does cross into the ecliptic, okay? So Ophiuchus, our snake handler, is our 13th zodiac constellation. Okay. Yeah, you're very welcome. I will mention this before I sign off completely. Feel free to join us for our next show next Friday, where we'll have our Kaler Science Lecture. Waylena will be taking the helm for the Prairie Skies Spotlight on Mars missions, and then we'll have another Where into Prairie Skies the week after that as well. Now, all right. The Beatties have asked to look for Neptune. If memory serves, Neptune is actually in the constellation of Aquarius right now. So let's go ahead and go up a couple of hours into the future. Okay, so there's Capricornus right there. And I do not I have to admit this, hopefully I don't get fired for this, but I cannot really connect the dots mentally as to where Aquarius is when I'm looking at this. I just know I need to
Ever
click
been
right
able to do
around.
that?
And I clicked on Pegasus without thinking because of what I'm looking at here. See, there you go. But there's Aquarius. Just, can you really see it, Waylena? What do you usually use?
I've not been able to.
Yeah.
I just go with the square of Pegasus and follow south from
Maybe
that.
that's what I should do. I just gave those little pointing suggestions. I should do that from now on. I'll give you folks another example of this because this is a really great point that Waylena just made. We often use the Great Square of Pegasus to do things like pointing to the Andromeda Galaxy, which I don't see is displayed on my screen right now. I had the Milky Way off the entire time. Oops, that explains why that is. But right here is the Andromeda Galaxy, and it's pretty close to the diagonal from the Great Square of Pegasus. What I probably should do is take the other direction of it and point to this bright star that's right around the head of the water bearer. Not water bear, I'm not talking about tardigrades here, the water bearer, okay? And maybe that'll help me remember the name of this star, Sotomelech. You got to forgive me, folks. There are thousands of visible stars in the sky. I only remember about a few hundred of them. Okay. So yeah, here's Sotomelech right there. And now that we're looking at Aquarius, I'm now going to cheat. Let's press F3 to bring up my search here, because as we said, Neptune is not visible to the naked eye. So I have to look for it this way. There it is. Okay, that object right there is not the planet itself. That is just a star right next to it. Ooh, look at that deep blue color. I almost used the word azure when I try to describe this planet. And it is a deeper blue than what you see with Uranus, okay? It's a much deeper blue color, but it's a little dimmer than Uranus is because they're about the same size, but Neptune is about 50% farther away from us, okay? So that's why Neptune wasn't discovered until about 65 years later, in fact. Both Uranus and Neptune, since they're so dim, they actually had to be discovered by astronomers as opposed to having been known for thousands of years. But there's Neptune there. In addition to seeing Neptune, you folks might notice a couple of other things there, don't you? See a couple of dots. That's because Neptune does have its own set of moons. Not as many as the other planets like Jupiter, Saturn, or Uranus, but a lot more than what Earth does. Neptune has 14 moons that we know of so far. And then Neptune has another thing that we don't have around Earth. Yeah, like the other gas planets, Neptune has its own ring system. Okay, so you do see that Neptune has some dim rings, but we didn't know Neptune had rings until we sent a spacecraft to fly past the planet over 30 years ago. Okay, yeah, the Voyager 2 spacecraft flew past Neptune in August of 1989. Probably right around the time that Betelgeuse was still in movie theaters. But they were able to see those rings after it had flown past the planet right there. Okay, now, if you want to see Saturn, yeah, Saturn's the one that's the most photogenic. For a lot of people, Saturn is their favorite planet to look at. It's also the one that when we look at Saturn, when people see Saturn through a telescope for the first time, they actually think we faked the picture. It really does look fake to them. All right, we said Saturn was right next to the sun. This one is Venus. Saturn's got to be this one right here because Jupiter's there. There we go. Let's go ahead and zoom in on it. I might turn off the artwork so that the goat's beard doesn't get in the way. All right, we see lots of moons there. That beige one just down and to the left, that's its largest moon, Titan. Titan is a really big moon. It's the second largest in the solar system. It's actually bigger than the planet Mercury. Oh, there it is. There's those rings. Can't miss them. All right. Yeah, beautiful to look at. The rings are really the shining jewel of when you look at this thing through a telescope. If you've got a really good telescope, you might be able to see that dark gap in the rings right there. It's referred to as the Cassini division that you see right there. The reason why there's a gap in the rings is because the ring particles, each of these rings, none of them are solid. They're made up of trillions of bits of ice. They can actually get moved around by all of those moons that are orbiting around Saturn. Okay, so the gravitational pull of those moons kicked out most of the particles in that area around Saturn's rings. So it's a lot dimmer right there. Okay. Now, Jermaine asked a great question about the Southern Cross. I'll be happy to show that to you, but we have one major limitation about the Southern Cross. The Southern Cross is called the Southern Cross because primarily we can't see it in the north for the most part, okay? You have to travel farther south than where we're at in order to see it in the sky, okay? Now, the other cool thing about the Southern Cross is that the Southern Cross works for people in the Southern Hemisphere in the way that the Big Dipper and the North Star work for us in the Northern Hemisphere, okay? And we have to do this because the Southern Hemisphere has no South Star, okay? So here is going to be the quick and dirty way I'm going to show this to you all. I'm going to take away the ground now. Ooh, now we're floating through space. Okay, so makes it a lot easier. All right, so now you're looking at a part of the sky we can never, ever see in Champaign just because of our latitude. We see a really lovely, bright part of the Milky Way galaxy down here. And I have to tell you folks, if you've ever heard of the concept of astrotourism, the biggest thing that you'd want to do with astrotourism is travel to the Southern Hemisphere just to look at the stars and our galaxy and the other stuff that's down there, okay? I've seen only a tiny taste of it, and I know that it's a treat, okay? Just looking at the photographs, well, I know the photographs are doing what our eyes cannot do, but just seeing how much is down there tells me why I need to see this stuff. Okay, so our Southern Cross, it's actually in the middle of the band of the Milky Way. It's right next to these two really bright stars right here. These two really bright stars, one of them is really bright because it's actually the closest star to us. This one right here is, you see it says Rigel Centaurus down there, but we usually call this one Alpha Centauri. You've probably heard of that one. The stars of Alpha Centauri are only 4 light years away from us. What does that mean? It just means they're the closest, okay? No other star is as close as that to our solar system, okay? This one here is Beta Centauri, and then to the right of that, you will find our Southern Cross. You see right here, they gave it the Latin name Crux right there. That is the Southern Cross. I'm going to mention this just because you wanted to see the Southern Cross. I'm trying to find the false cross, but I haven't looked down here enough times recently. You know what? I'll give it up right now. I already showed you the right way to find the Southern Cross, but there is a, oh, is it this one here, Waylena? Is it these 4? Is that the false cross? It looks almost like it.
I honestly don't know which one is the false
That's
cross.
okay. That's all right. I shouldn't be going off on these tangents.
I've never been to the Southern Hemisphere.
And I was there during its winter time in Brazil, so I was not that far south, and there were a lot of clouds. But I saw the Southern Cross.
Field trip. We need a field trip when traveling is allowed again.
Exactly, exactly. Yeah, they had to go and have a total eclipse of the sun right in the middle of a pandemic. What were they thinking? Couldn't they reschedule that total eclipse? All right. Okay, so sorry about that, folks. I hope you enjoyed my little distraction. So the Southern Cross is right here, and these 4 stars, and I know there's a little 5th one right there that's also quite bright. If you draw a line from those bright from those bright stars along the longer end, that will help you find the South Celestial Pole. So here is that cross length right there. We're going to do 1, and it's probably a little long, 2, 3, 4 cross lengths. Hopefully I did that all right. And now I'm going to go ahead and press this button. I'm going to press this button. Hey, not bad, not bad. That is the South Celestial Pole. So notice that the South Celestial Pole has no bright stars. That's why we have no real South Star right there, okay? But if you look at Southern Hemisphere countries, quite a few of them have some stars on their flags. Look at Australia's, look at New Zealand's, look at Brazil's. They will have the Southern Cross on there. And that is because in navigation, the Southern Cross was essential to helping find exactly where the South Celestial Pole was so that they could know exactly which way south was. All right. It was just that useful. Now, another cool thing you can find in the Southern Hemisphere, let me turn off my annotations for a second, and I'll turn off that grid pattern as well. Very close to where the South Celestial Pole is, you can see a couple of fuzzy spots in the sky. What you are looking at right here are the small and large Magellanic Clouds. They got named because apparently for Europeans, they were never seen until Magellan sent his mission going to sail around the world. And as soon as they got to South America, they started seeing these fuzzy spots in the sky, and that helped them find. And that they saw they stayed up there in the sky. They had no idea they were looking at neighboring galaxies to our own, but they got the names of these large and small Magellanic Clouds. If you want to see what they look like up close, there's probably a good picture here in Stellarium. Yeah, that looks nice. Ooh, yeah, look at that. Lots of stars. The red stuff there are areas of lots of star formation, all sorts of cool things. They're basically satellite galaxies to the Milky Way right there. All right. Did I get any other? Yeah, you're very welcome. Okay. Any other requests or comments?
Well, let everybody know that the recording of this session, we'll be putting that onto YouTube if you want to go back to check it out. And as Erik already mentioned, we're going to be having next week, we're going to have our science lecture at 7. And then following that, we'll have a Prairie Skies spotlight on Mars. Very excited about the upcoming landing of Perseverance rover. And look for short videos coming out from us in those coming weeks on Facebook and YouTube. About the mission and just general cool Mars stuff, our favorite Mars things. And then on the 18th, we'll be having a lot of online live activity for really to celebrate the landing together.
Absolutely, absolutely.
I'm so excited about this
Yeah.
because you guys, it has a helicopter.
Yeah, it does. It's called Ingenuity. It is so amazing. Yeah. All right. Well, folks, thank you so much for joining us. And we hope to see you again soon.